So just let me quickly know if you have your data sets. It is in your Drive link and you can find the dataset from there. The file name is heart.csv. If I need to wait, then also let me know in chat. I'll be waiting for the responses. Okay, just let me know if you are doing it or not. Just help me to know whether I should wait if you are doing it or not. Okay, no one interested to respond. Fine, then I'll start. And I just hope that you people will get the idea. First of all, as you already know, we just need to get your data file here. Students, I just request you, this is a very humble request. Please respond in chat. It just takes a few seconds to type your message and put it in chat, just to update me that something is happening on your end also. Because this is very bad if I'm taking it one-way session and you have no responses to give me. The first step we are doing here is to upload your dataset. I'm repeating it again. We have done it so many times, but still, if anyone is stuck that how you get your dataset, you have a upload button right here below this files option. We have upload button. You can click on this and then go to any folder on your system wherever you have kept your dataset. This is the dataset that I have shared with all of you. You may be getting it from the link on your Drive that is already shared in chat. So this heart dataset I'm getting here, and it will be loaded in the form of heart.csv right here. Those who are doing it, kindly update me if this dataset is ready here in the files section. If no one is doing, then also let me know in chat that we are not doing anything and we are just listening. I'll just wait for a while for the responses. Anyone who has any problem in loading this dataset, then also let me know. If I need to wait more, let me know. If the dataset is ready, then also let me know. Okay, fine. So I'll just consider that no one is doing it side by side. So I'll just follow the steps. First of all, we have to load the data set. The first step I'm adding here. And as we know, first we need to import pandas as PD. Then we need your data variable pd.read_csv. And inside this, we need to copy path. And we can insert it right here. And after this, we can look after a few lines of your data. So these are the first few lines of data we can see here. And this includes a mixture of data. We can see categorical variables as well as numerical variables in this data set. And this last one, this heart disease, this is your final variable on which you have to do your prediction. And based on the theoretical discussion that we have done on the second day of this course, we have studied that if your target variable is in the form of classes, like a limited set of group, such as here we have 0 and 1. So this becomes your classification problem. So right after observing your target variable, since this is a heart disease prediction data set, so it has two categories. If the patient is having some disease or the data is from a healthy person. So 0 represents a healthy person, 1 represents if the person is having a disease. So both these things we are trying to analyze here, and we'll just classify it based on your machine learning model. So this is the first most task we have done here, to load the data set. And then we can just start observing some initial information about the data set. So this is like a get basic info about data, a task I'm adding here. And then the first one I have shared in the snippet. So if anyone is doing side by side, they can take code from the cell. And because I'm just explaining everything here side by side, because I'm not getting any responses, so I'll not be asking it again and again. But if anyone is stuck anywhere, they can ping me anytime in the chat. So we are just getting the basic info about data now. And this is like data.info. This command we have used several times by now, and you already know that how it works. So let us check basic information about your data. And what it says, we have 918 entries, which means 918 rows in your data set. And we have 12 columns in this data set. So these are two important details we are getting. After this, we can see name of every column here in the list. So whatever distribution we have for the features as well as target variable, we can see that here. And then data type of each variable, and you can easily see that this is a mixture of object entries and integer entries. So we may need to process them separately. We have a specific set of operations for the object categories and another set of operation for the int categories. So both of them we may have to execute one by one. So from the middle one, we can also observe that there are no missing values in data. It shows that the total number of entries are 918, and even in this middle column, all these show 918 entries. So it means they all contain relevant data. There is no missing value in your any of these columns. And as we know that we can also re-verify this. So if we have to check missing values in data, so if anybody interested to share the small set of code to check missing values, we have executed that many times now. If you can just tell me how we check missing values, there is just a small syntax you have for this. I can just wait in chat if anyone wants to post, then otherwise I'll be writing it. the code to check missing values in your data. Okay, fine, no responses. So we can have it data dot is null dot sum. So this thing we have done many times, and as I told you, you can use isna operation also for this thing. So both of them help you to find number of missing values in columns. So we can just run it, and there is 0 in all columns. So it just means that there are no missing values in your data and it is clean right now. So after this, let us check value distribution in your data. These are some initial tasks to observe your data so that we can make decisions about how to deal with it, every part of it. So value distribution, we can check simply by using NUnique. We have used this one also in previous session. So this will basically help you to understand distribution of your categorical as well as numerical variables. So here we can see unique value count in every variable. So all of them can be displayed instantly over here, and with a quick observation, you can just quickly identify which one of these are your continuous variables or numerical variables, and which one of these are class-based variables or categorical variables. So if anyone can identify any of these, if you feel like this is a continuous or this is a categorical variable, you can post me in the chat. I can look for the answers. If you can identify which ones are your categorical variables in this. Okay, so after this, I'm just updating another task. Just as a description of this, what we can see is, just by observing these things, target variable we have already identified, that is your heart disease variable. This thing we already identified. Then we have categorical features or variables, whatever you can call. So let us see which ones of these are categorical variables. The second and third feature, first of all, your gender information. Then we have chest pain type. After this, we have, I think, yes, fasting BS. This one is your another data. These are basically your patient recordings, whatever we have observed from the patients, those things are being updated here. Then we have resting ECG of the patient. After this, we can see exercise angina. And then we have ST slope. These are your categorical features, and then we can have your list of numerical features. Just for indication, I'm putting a list here. First, we have your age variable. Then we have resting BP. This is again your continuous variable. After this, we have cholesterol level. So that is also a continuous variable here. And next to this, we can see max HR. This is another numerical variable. And one more we have is your old peak. So these are all your categorical and numerical variables as well as the target variable. So we have this kind of mixture in your data set. One more task that we can execute on this data is check distribution of both classes in target variable. This is another important analysis that you may have to do on your data structure, because we need to just understand how well your target variable is distributed between both categories. So for this, what I can do here is I can write here, this is my target variable that I have to use, this heart disease variable. And then we have value counts. This will quickly help you to understand how both categories are distributed, such as we have 508 entries belonging to one category and 410 entries belonging to 0 category. And in the top, we have seen the total number of your entries or observations are 918. So this is a distribution from these total number of entries. We can see they make total 918 entries. So this creates your final distribution. And let me just share all these small codes in the snipper as well. So the list of variables also I have updated in the snipper for your quick update. Then we have distribution of both classes. This also you can find in the snipper. If anyone is doing, they can find the code beside this. So after this, we can, these are just some initial analysis we have conducted. We can do many other things also on this particular data. But going further, we have this exploratory analysis that we can start with, or we precisely call it exploratory data analysis and EDA on this particular data, so that we can just understand what type of details we can find inside and what kind of distributions we can plot from this. So that we are trying to identify over here. So depending upon what kind of features we have in the data, we can create variety of plots out of this. Many of them we have already seen with the previous day's data set. So here we'll be using few of them. First of all, for example, let us create a simple distribution for your gender information. Like I'm updating here, check visualization for gender details in dataset, so that we can just observe how the heart disease patients or cases are reported among males and females. So that quick information we can get from this gender details. So first of all, let us see a quick update on value counts of this again. Same as your target variable, we can check the distribution of gender information as well. And you can see this shows that there are more cases from the males and lesser number of are reported from the females. And accordingly, you can even apply different types of filters. Yesterday, we have also seen variety of filters that you can apply. Maybe if someone asks you that how many cases of disease are present in males, so you can apply your filters now. You know that you just have to select male category from this gender column, and you have to select one outcome from the target column, and you can just apply that filter to check your exact distribution. Same you can do with the female categories. So those all things we have discussed already, and I hope that you can apply them easily. Currently, for instance, I'm here updating the plot, since we are trying to get a visualization of gender details over here. So for this, I'll be creating, we can have different types of plots. So for instance, I'll be creating a pie plot for this quick distribution. And as we have done it yesterday also, your pie plot we can create from the matplotlib library. So first of all, I'm just importing matplotlib .py plot as PLT. So I'll be updating this. Next to this, we need to create your data distribution that we want to plot for this particular thing. So that we can create instantly. For this, first of all, plt.py, because I want a pie chart. And inside this, I'm updating first the name of the column on which I have to apply my operation. And since the pie chart will be created based on the value counts, that will show the distribution around. So we are applying here the filter of value counts and few other adjustments that we can make with your this variable just to enhance the plot. What we can do is we can add labels on this plot so that we can precisely look after the variable distributions. Although pie chart can be created directly also with this, but let us modify some variables so that we can have very precise details about both categories. So from the variables, again, I'm applying distribution with specific index values from every category so that we can have that precisely. And then auto PCT, this is just to display if you need your outcomes with a percentage distribution or pie chart. In mathematics also, when you create pie charts, you just add the percentage information in them. So the same I'm updating here. This is for updating percentage information with one floating point digit, means after decimal we need only one digit. So that information I'm updating here. And then probably we can also have title of your plot. So for instance, I'm writing here male female ratio in dataset for which I'm creating this plot. And just a minute, I need to update this. Last one we can have is plot underscore plot.show, and I'm just running this here. And this is your ultimate outcome we get from this particular plot. I just tried to explain every part of it. If anyone is confused with any part of this, please ask me in the chat also. Otherwise, we are just getting this outcome here, as I have shown you from here also, that we have majority of readings from the male category and minority from the female category. So the same we can see here. From the female category, we can see only 21% data. And from the male category, we can see this approximately 80% or we precisely 79% data. So I'm just sharing this in the snippet. If anyone is executing, they can get this code right from the window there. So these are the one type of plot we have created. And now let us start with maybe some other variable if you want to create a plot with. So for this, let us add a task here, like distribution of your heart disease cases or heart disease classes, whatever classes we have, between gender categories. So I'm just updating one task here. We need to create plot to see distribution of heart disease classes. 0 and 1 we have in case of heart disease, and for the gender categories we have a male female out there. So there are different types of plots again that you can use for this, but I'm using here one simple count plot. You have already learned how we create count plots. So the same example I'm taking here. Import Seaborn as SNS because count plot we create from Seaborn library. And after this, we have SNS count plot. And inside this, we can update data is equal to data. Since we are working on the data variable, so I'm making this equal. If you have any other name for your data variable, you can put that name also. After this, on the x-axis, I'm updating my gender information. And then the color description, as we have done in the previous classes also, hue represents your color information. So that I'm dedicating on the basis of heart disease, so that we can visualize this based on both categories available in heart disease case. So you can see here, in case of male category, we can see here, these 1 cases are more and 0 cases are less. Similarly, in case of female categories, 0 cases are more and 1 cases are less. So as a general observation, we can say that the heart disease cases are reported more frequently or more popularly among males in comparison to females. That information we can just quickly visualize from here. So I'm just updating this code also in the snipper. So if anyone is creating these plots, they can find the code over there. After this, we can create analysis on one more variable. I have just created one list here in the beginning. The type of plot that we choose completely depends upon type of feature that we have selected for the analysis. So currently, as we are doing these analysis on your categorical features, I have done on this gender information, as well as we have executed a relationship between your heart disease and this gender information. For all others, you can create similar kind of plots. Let us take just a few examples. For instance, I'm adding one task here. Just if you want to check distribution of chest pain types in dataset. So there are different cases of chest pain you will see in your dataset. If anyone is interested to explore the official source of this dataset, you can easily find it on Kaggle platform, such as here we can check it on the Kaggle platform. On this link, I'm sharing this link also in the chat window. As well, I'm just inserting it in the snipper on the top. So you can find the official source of data also over there. So what you have in this particular data set, we have a range of entries from the cardiovascular disease, because this is one of the major issues. So they have just brought up some stats about the disease cases here, and then the attribute information also they have updated here. So currently I'm talking about this variable, chest pain type, and there are these 4 different categories reported: typical angina, atypical angina, non-anginal anginal pain, and then asymptomatic pains. These are different types of chest pains that heart disease patients may face, or these are the common experiences that patients report. So based on that, they have created a variable here. And currently we are just trying to observe that which one of these category is more prevalent in your data set. So for this, first of all, we can use the simple technique that we have used with other variables also. Like I'm selecting this variable, and then your value counts function we can apply here, just to see the quick distribution in terms of numbers. And what it says, if you just check the observations, we have these 4 types of pains here. This asymptomatic, this shows 496, which is the highest. So we can just say, we can just report from this data that there are more cases of heart disease with asymptomatic chest pain type. So this can be an important observation when you are working on some research data, and we can just report it as a essential finding over there. Then further, maybe if you want to create a pie plot out of this, that distribution also we can see. So one way to create pie plot I have shown you here. This is one way we have already used. Another simpler way I'm adding up here just to help you understand that there are so many ways to do the same thing. So data group by function, we have used this earlier also. So this is not new. In the previous sessions also we have used this. If anyone needs any explanation on this, I can provide if anyone posts that in the chat window. So we have here chest pain type. I want to group my data based on this. And then the size information, because there will be 4 different categories. So total size first of all, and then grouping based on different types that we have for the chest pain inside this. And then we have to create your plot. So inside this, I'm writing type of plot is pie plot, and then your fractional values as well as percentage count that we want to see, that I'm updating here. For instance, we need percentage 0.1f again to see your single decimal value after these percentage updates. So let us see what we get in the output. So this is your pie plot now. We can see majority of region belongs to your asymptomatic conditions, and these 3 are the remaining. So this kind of plots, again, you can utilize for reporting your findings out of your initial data. I'm sharing this particular code also in the chat window, in your snipper. And I think the previous one also I have not shared, so I'm updating this one also here. So these are your 2 kinds of plots we have created with a heart disease patient. For first was for the gender information, then for the chest pain type. Even if you want to see the distribution of this chest pain type with respect to heart disease cases, that also is possible. You can use this kind of plot again. Sorry, a count plot you can utilize again to create your this chest pain variable information. For instance, I have taken that the same one, and I'm just changing the variable type here, this one, with respect to your hue category. So let me just run it, and we can see these observation. This asymptomatic shows highest number of heart disease patients and remaining are less. So these kind of things we have observed here also, but this is with respect to your heart disease cases now. So more patients who have asymptomatic condition with chest pain report heart disease case failure also. So this gives a quick introduction about how your these pain conditions are affecting the final outcome variable. So I'm sharing this one also in the chat window. Okay, so up to this, I have done some analysis. Still, I'm asking one more time in chat. If we are all good up to this and you are performing something, you can update me in the chat. If we have anything to discuss, whatever we have done till now, just let me know. If I need to explain anything, let me know in chat. Anyone who is interested to report in chat, please update it. If we are good to go up to this point. If anyone is interested to take up the task also, I can share. Because otherwise I'll share task and you people will not respond and will again waste some time. So just requesting you, if anyone is interested to take up a task on this categorical distribution, similar kind of plots if you want to create, I can share a small task also for the next variable. Kindly respond in chat if you are performing or not. Okay, I cannot see any responses, so I'm going ahead with the next task here. So let us again see a distribution with next variable, distribution of fasting BS category. That again we can see. So I'm executing one more task here with the same pattern. I'm just trying to execute every task so that if things are getting repeated also, that also will make things clear for those who are new to this. So again, the variable I can pick up is your fasting BS. And along with this, we can have value counts here. And we can just see the distribution of it. So again, you can see we have 0 category with 704 and 1 with 214. And what this represents, basically, you can verify it from the official source of data. So this one is here. So this is your fasting blood sugar level of the patient. 1 represents if fasting is greater than 120 value and 0 otherwise. So this threshold they have created. If this is greater than 120, then it will be reported as 1, otherwise 0. So the same details we can plot also, or you can even plot it in the form of pie chart or maybe count plot, or even check relationship with respect to heart disease. So let us create one simpler plot here. I'll just check the relationship with respect to heart disease for this. So we can use this previous code and we can insert it here, and we can utilize your fasting BS category in the x-axis, and all other things will stay the same. This is very simple. Once you have learned that how you create one kind of plot, then you can do it with any variable in the list. So this creates your fasting BS for the 0 category and for the 1 category of your heart disease. And you can see that this 0 category shows higher number of counts for both chances of heart disease and and healthy patients. In both categories, this 0 belong. And in one case, we have limited number of observation. So this is another kind of report you can generate from here. And let me just share this code also in the chat. I'm updating this in the snipper window. The previous one also I have updated here. So the same task you can execute with one more variable further. I'm just writing it here. And we can just choose your next variable, that is your resting ECG. This was your next variable in the categorical set. So for this, you can see 3 categories over here: normal, LVH, and ST. If you need to know more about this, we can go at this point, and here you can see this is about resting electrocardiogram result. So this is basically the ECG reporting we have from the patient after conducting ECG test. And here normal shows the normal range, and ST is having ST or T wave abnormality. So one kind of abnormality, they have shown it here. And then one more, we have LVH showing probable or a definite left ventricular hypertherapy, or this is a specific case of your disease condition again that can be reported with ECG. So these thresholds they have created, and based on this, you can find 3 different ratings over here. And again, you can check the graph with respect to your final variable. So you can just create any kind of plots. I'm just using some simpler plots here so that beginners can understand it easily. I just need to change the variable on the x-axis, and the plot will be ready with 3 different categories of this. And you can see here that we have more cases with the normal resting ECG, and even the heart disease cases were reported more in these cases instead of ST and LVH. So you can see variety of findings out of this data set. Depending upon how we need to achieve our objectives, we can use different types of plots or observation from every data element. So this is your resting ECG. I think the similar kind of plot you can create for one more variable that we have in the list here. That is this exercise angina. So for this also, if you want to see the observation, we can update that here. This one, we can change exercise in China. We need to use the same name as you have in your document. So we can see this in the outcome here, normal, and the second category. We can also observe it here, this yes and no category we have. So if there is something related to exercise, they have just created an observation on the human body. So how exercises are affecting both cases. If they are having some changes in their body type, accordingly, they are getting yes or no outcome over here. So for this again, you can create the plot here. I'm using the same code time and again, just to help you understand that the process is pretty simple. You just have to change the variables and you can easily do it. I have repeated it like 5-6 times, and I think even if you are not getting anything else, at least this thing will be clear that how we are doing this. Every time I'm just modifying the existing code only with a new variable, and I wish that this will be easier to create for all of you. At least a count plot you can create easily now. So here also we have two categories, no and yes, with respect to your heart disease. And it shows that in the yes case, we have a higher number of these patient conditions. However, in no case, we have higher number of healthy patients. So both things we can observe from here, and this can be again a important outcome for your medical analysis. The last variable that is left from your categorical list is your ST_slope. This variable also we can check with the variable count here. And this basically represents the slope of the peak exercise ST segment. So up shows upsloping, flat shows flat, and downsloping, 3 categories, based on how doctors observe this case, peak exercise conditions, and how it affects our body. So based on how doctors observe it, they have created 3 categories out of this. And we can see the distribution over here. And we can create similar kind of plot for this one also. You can use other plots also. I'm not using other plots because I just hope that if I use these simpler plots, at least someone will get the idea what we are doing here. If I use complicated plots, then you people will be again stuck, and as you are not responding in the chat also, so I'm not sure if you will be able to ask if you get stuck again. So I'm using the simplest plot time and again. So here you can see the outcomes for all 3 categories, and as we have observed from here only, we can see that this flat ST slope category gives you higher number of disease condition, so that you can easily just observe that how it works in your data. So these were your all categorical variables that we have explored using different types of plots right now. You can create pie charts, you can create count plots, you can even create different types of bar charts out of this. That completely depends upon how you want to see your data. Then now we can also have observations with numerical data. That also we can conduct. So for this kind of observations, again, we can have a variety of plots. As I told you in the beginning, that for the numerical data or for the continuous data, we can have different types of plot. So for instance, we can pick up one of the existing plots that we have already studied, and it can be like your distribution plot, or even we can use histograms. Variety of options are there. So first of all, I'm creating one with the first variable that we had in the numerical category. So it was, I think, age variable that we can see in the list here. We have this age variable. So let us see how it is appearing in your plot. So for this, I'm just picking up your Seaborn library, and I'll be creating here dist plot, distribution plot over your age variable. So I have selected the age variable here. So let us see what we get in the output. So this is your distribution plot. And this quickly gives you an idea that we have age distribution from somewhere around 30 we can just predict it around maybe 80 or slightly less than 80. As per the graph, we can see this, that this is the range of your age variable. However, if you want to be more precise, you can even check it with specific numbers, such as we can have data variable age right here, and we can check minimum value of it. So I can run this, and it says 28 is the minimum value. And similarly, if we want to check the maximum value, we can check that as well. So I can run this. So it says 77 is the maximum value. That is why we are getting this kind of plot. It goes from 28 to 77. And we can observe that your majority of cases are reported from like 50 to 60, we can say. Between 50 to 60, we can say majority of cases that are reported in this heart disease category. So this can be another important observation from your data. I'm sharing the code for this kind of plot right here. And then we have your min and max calculation that we can see here. All of these you can execute. Okay, up to this level, if anyone has anything to report in chat, any confusion, any question, or if you are doing it side by side or not, I can just wait for a while in chat. Anything you have to report in chat, you can just update me. Thank you for reporting, Vardhan. Anyone else who wants to reply in chat? The codes I have shared in the snipper window. You can execute it right from the beginning. It should work well. And the dataset loading, as you can follow from the yesterday's session, you just have to bring your data here and then you can start writing your codes. So I hope this should work on your end well. Thank you for reporting. At least one student reported. I don't know what others are doing, but let us go ahead with one more analysis. We can just take it into the functions also. Let me try one more technique here. Categorizing your age variable. Currently, we have age variable in the form of your continuous variable. I'm just taking one random case here. If you just want to change the type of a certain variable, that also is possible in your data science. We have different operations, possibilities for that. So for instance, I create a function, and what I'll do is, currently we have a distribution of data from 28 to 77. Let us consider that we would create 3 classes from here. Like we will take maybe 28 to 40, we will take youngsters. Then 40 to maybe 60 or maybe 55, we can take like middle age or whatever name you want to give to the data. And then above 60, maybe we can consider elderly. So we can convert it into 3 classes also. And based on that, we can even give our findings that yes, the cases are more common among middle-aged people, not among your elderly or youngs. So we can have different types of reportings out of this. We are just doing this analysis to learn one more thing, that it is even possible to convert one type of variable into other type. So let me do this here. I'm using a function definition. Function definition we have learned in the beginning sessions, and I hope you already remember that how we create functions. So we have a defined keyword always in front of your function that we can utilize to create your function statements. And age, or like maybe yes, age, I'm giving name of the variable, and inside this name of the parameter also I'm giving age. You can have different values, that is your choice. For example, if I want to change this like age range, I can give name of your function. Function creation we have learned already. So the same concept I'm following here. This is your keyword that we use to define a function. Then we have name of the function, and inside this we have parameter of this function. After this, I'm creating different conditions because I want to categorize this into 3 sections. So let us try a random technique here. If age, we just need to compare this age. If age is less than, for example, 40, one case I'm taking, it should return, maybe we can say young or adults, whatever you want to use. I'm just using some random details here. One category less than 40, I'm considering as young. Then second stage, elif case. This kind of function, if else statements we have already learned. So the same concept I'm using here. Let us consider if age is greater than equal to maybe 41, that is your next window. And age is, for example, we can take like less than maybe 55 or 60. For instance, I take it 60. Second case, then it should return maybe middle age. You can have any name of this. And third, if we need not to have, we can use even else, because all the remaining we will put in the another category. So for this, what I'm writing here is return elderly. So these 3 categories I have created from the age variable, and this should return me the function with new age values. The output will be new age values. First, I need to just save this function. I have to run this so that it gets saved in the memory. So let me run this. And we have these 3 classes now. I can apply this on my age variable. So see how we can apply. There are different ways to call a function. I'm just using one way out of them. So what I'll do here is, first of all, I just have to choose the variable on which I have to apply this operation. So this is age variable. And after this, I have to apply function. So I'm writing here apply and then name of function. This is the name of function, age underscore range. So I can just apply it. Now it will be applied on your age variable right from here. And after this, we can even check your data set just to see if age variable is changed or not. Maybe if you want to see it before applying function, that also we can see, so that we can just compare how it appears. So this is your data head before running the previous, the new cell. This is currently the age variable. You can see here. These are the values in your age variable right now. Now I'm running this one, and then we will see the head again. Let me run this, and this is your new head. The age is now converted to a categorical variable. Just a random technique we have learned, that how you can modify one type of variable into other type. So I'm just sharing this small function in the snipper window. And then I'm just sharing this updated value by applying function. So this one also I have shared in the chat. In the similar manner, we have many other such columns that are numerical in nature. So we can see them on the top, like you have. Yes, we have resting BP, cholesterol, max HR, old peak. So for each one of them, if you wish, you can convert them into your categorical data. You can process them as it is also. That is an option as well. So, okay, just I'll ask in the chat again. If anyone is interested to give it a try, if you want to create a function for resting BP, same as age, you can create, you can give any names to 3 categories. Like you can give it low, medium, high, or bad, good, moderate, whatever you want to give name as the classes. So if anyone is interested to try, we can convert one more variable into categorical. I have shared the function for age. It is already here. You can modify this one and the new value will be ready. Just update me in chat if I should give this task to anyone who is interested. Then I'll wait for their response. You can take as much time. Just try to implement if you want. Just first ping me in the chat that you want to try or not. Yes, no, anything if you have to update in the chat. Any responses? Okay, nobody interested to respond. Okay, then I'll create this type of function just one more time. So if anyone is interested to learn what we are doing in this function definition, I'm making one more function here again. So I'll just take this one. How you can apply the same on another variable also. Let me show that. So let me take it for the next variable we have is resting BP. For this one, I can write so this is the another task I'm adding here, and we can follow the same sequence. I'm just modifying the previous one so that you can understand how well you can do it with any variable. So first we need to choose the name of the variable. This one I need. And I'll insert this one here because we'll be iterating through this mainly. So I can give it the similar kind of name. And outside this, you can also give it a new function name, resting BP range, I'm giving it. And first, let us check the minimum and maximum value of this particular variable so that we can apply our filter accordingly. So for this, what I'm doing here is minimum of your data. This is the variable for which we need to check minimum and maximum value. The same I can apply for the max as well. So I'm just writing it here and let us see. We have it from 0 to 200. This is the range of resting BP from 0 to 200, the min and max values we can see. So based on this, you can apply some filters again. I'll be applying some common filters here. For instance, we have this. I'll use this value. So because we are iterating through this, so resting BP maybe less than 50. I'll take first condition. So we will say it low. I'm just giving some random name just to teach you how we can operate through functions. Second, we have resting BP with greater than or equal to 51, and maybe we would like to take it up to 120. And here also we have to update the variable. And the outcome I can update here is like maybe moderate. And the last remaining category I want to put is maybe high. So these random 3 conditions I have created from resting BP. And I can just run this operation. So your function is saved now with this name, and we can apply it in the similar manner. Using this, we can apply. Currently, you can see resting BP has these values. These values are currently available. We can convert them now. So I'm just updating it here, and I'll be changing the variable name that we have to handle. So here I have added it. Here also I have added it. And the name of function also I have to update. So I can take it from here and we can just update it in this portion. Let us see the outcome. So now you can see resting BP also is updated. And maybe if we want to see if we have different observations out of this now, so we can even try your data value counts so that we can just visualize how well it is categorized between all three cases. So it will be value counts here. So see, this is the distribution that we are getting right now. So this seems like a bad distribution, we can say. So it is better to update the condition so that we can have a better distribution. So for the low, we may need to increase the range. So let us see what we can try here is maybe for the low category, I can take it up to maybe 70 or maybe 80. And then from 81 onwards, I can take it up to maybe 140. And then the remaining ones we can have. So let us see what happens if I change this range, what we can get in the output. Let us observe. So this is a new function now. I'm applying it here. Okay, so the variable is already refreshed. So just let me go on the top. I need to refresh it again. That is one problem when we use same variable names. So let me just refresh few cells. So first I need to refresh this one. This brings your data head. And then we can apply your age function again. And this is the fine one. We can again look after this variable and now we can apply the new range. So the function is here and we can run this now. And I can also check outcomes. So still we have low category, probably looks a bad idea. We can have only 2 classes out of this. That will make the outcome better. So these kind of observations you may have to do time and again, that how the conversion may be like a well-looking conversion that will be valuable in your data set also. So for this, what I can do is I may need to refresh the variable again, but let me just first update this one. I'll be using 2 categories only. One will be your up to 120 and above 120 equal to, I'm taking this, and above this, everything I'm considering as your high. Or you can even take it from 0 to 100 and then up to 200 as second category. So both of them you can use easily. I'm using just one random value here. And I need to refresh the variable again because I have used the same variable name here. If anyone is interested to ask anything about what I'm doing here, they can put me in the chat box. I can answer accordingly. So this is the new category we have created. The filters you can apply as per your choice. So one we have created here with high and low condition. This is another kind of distribution you can create from your data. So after this, up to this point, we have just converted variety of your variables, and you can even do the same with remaining variables that you have in your data. Maybe you can even convert all your numerical variables into categorical variables, but that completely depends on the requirement of your data. So if it is required, then only you should update. Otherwise, you can process them directly as well. So currently, we are here up to the initial analysis or exploration, and some feature conversions also we have done. Let us check the data type again. What data type, or you can use info function also. Check data type of variables, because we have changed many of them. So let us see what is the current status. So we can have D types function. This will help you to understand data type of every variable. So we can just run this one, and you see now even the object as well as chest pain, resting BP, these two basically we have converted. They are also object entries, and there are few int entries also that we can see in the distribution. So we have both type of outcomes in your this data right now. So let us proceed further with one more task, because we have to build a machine learning model. And in order to run a machine learning model, you need target and features. I have discussed that in the previous session, but if anyone wants me to repeat that again, please let me know in the chat box. I can repeat everything again. Otherwise, I'm just proceeding ahead. Now, what we are doing here is we are separating features and target, because we need features to train your model, and target will be the response variable for which it has to make predictions. So there is a simple technique to do that. I'm using X variable to store all my features. So this will be in the format that I'm using here. So for instance, I want to drop heart disease column. So that I'm writing here, dropping heart disease, and this will be dropped from column axis, because heart disease in a column axis. So axis 1 we have written here. If you are dropping something from the row axis, you can write here 0. We are dropping an entire column, so that we are doing here. Once you are dropping this one, all remaining features will be in the X, because we are dropping only one. So all remaining features will go into X. And similarly, we can have only target variable in your this Y variable. So this will become now, what we have here is, this first one is your feature variable, and the second one now is your target variable. You can even check shape of both of these, shape X and shape Y. You can check just to know how your features and targets are distributed. So you can see 11 features, 918 rows. This is rows into columns. I have discussed this earlier also. Number of rows and number of columns in X, and number of rows and number of columns in Y, because Y has single column, so that one is not displayed by Python. So it just shows you number of rows when there is a single column. So that we can see here. After this, as I told you in the beginning also, and previously also, we have discussed that the way to deal with your numerical and categorical data set is usually different. We have to transform them as per the requirement, and because ultimately your machine learning model needs data set in the form of numbers. So we have to convert even the categorical variables also into numbers. So how we can do that? I'm just adding one more task here. We can say separate categorical and numerical features, so that I can update them in a separate pipeline, and then definitely we'll be joining them together to get your complete data set. But because same operations we cannot apply on numerical and categorical data set, so I have to first create a pipeline for both of them. So first I'm getting here data underscore num, means numerical features I'll be storing in this. And how easily I can separate your numerical features, you can see here, I'm writing a function select data types, and inside this I can choose what kind of data types I want to include or exclude. You have operation for include as well as exclude. I'm using here, for example, exclude, And I have to exclude object categories in this case. So it will just exclude all the object columns, and remaining we have our numerical. As you can see from here, object entries are the one that we want to put in the categorical set. All the remaining numerical values it will put in your data underscore num, and we can even check that using your head function here. Let us see if it is working fine or not. So these are your numerical variables right now. Two more were there, but we have already converted them. So now they are object variables. If you converted these also, then they would also have been object variables. So then we could provide a complete analysis on single pipeline. But now we are having two pipelines. Next, I want to have your categorical features so that I can process them separately. So I'm just taking up this one, and then I'm creating one more variable here. That will be your cat variable or categorical variable. And inside this, now I'm including object, or you can just use include num type variable or int type variable or float type variable. All those things you can do. So I'm just writing here include object, so that all object entries get into this particular category. You can see all object categories here: age, gender information, chest pain type, all these things are now in the categorical details. And now for both of these, you have to apply different operations. If we talk about the general procedures in your data science, what we have is, for your categorical features, we have different transformations. We use encoders to deal with categorical variables, and we use scaling techniques to deal with numerical variables. Normalization and scaling go ahead with the numerical variables. We just have to bring them down to the same scale. And for the categorical variables, we need to use your transformation from object entries to your numerical entries. So I'm just using them step by step. If anyone needs detailed information on this discussion, I can provide that. Let me know in the chat box. Otherwise, I'm not going in depth, because I think none of you are implementing it side by side. So I can just save time and we can just execute. But if anyone is really interested to know, I can repeat everything again. Just please let me know. So what we have next here is, I'll be converting, or I'll be transforming categorical variables. And inside this, I'll be using an encoding sequence that I can update like this from sklearn. From sklearn library, I need to go to the pre-processing module, and from there I can import ordinal encoder. This is an encoder that can help you to convert these things into numerical values. Now I have to initialize this particular encoder, and I'm using enc variable, for example, for this. And I want to have outputs in the form of int variables. So I'm just updating the data type, because I need outputs in the form of integers only. So that I have updated here. And then enc.fit I'm using here. And this I'll be applying on your categorical data that I have saved in data underscore cat variable. So I'll be just using this technique over data underscore cat variable. And ultimately, we'll be getting your encoded variables. So for this, I'm using a data frame function over here. And then I'm using my transformer here. I'll be transforming this, your categorical features over here. Then we have your columns. So I'm updating here what column names we need to preserve, that also I'm adding here. If anyone needs details description on this code, I can explain that. So we have this one now. Let us see how this data appears. We can just check head of your encoded data. So now you have this in this form. We have just converted it into numbers, and those numbers will be the encoded form 0, 1, 2, 3. Accordingly, the classes will be assigned over here. In the similar manner, you can even convert your numerical features. You can just change them into your scaled down features. So that operation we can conduct on your num data type. So the technique will be almost similar. I can just add one more here. We are adding here normalize numerical variables. And here I'll be updating one simple sequence from sklearn.preprocessing module. Again, I have to now import. I'm using just one type of scaling technique, that is your min-max scaler, for example. And I'm just updating it inside your min-max scaler function. And after this, I'll be encoding it. For example, scalar.fit, I have to apply on data underscore num. And then we can transform it. So I can write here scaled variables with your scalar.transform data underscore num we can apply. Since I need outcome in the form of data frame, this originally gives you outcome in the form of arrays, but I need data frame. So I will again use a converter here, data frame. And inside this, I'll be just preserving my column names also, same as this we can use. Same as this, you can preserve your column names from here. If anyone wants to know in detail about this code, let me know. I can explain it in more in depth also. So we have numerical columns preserved from here. And this is your scaled head that we can see right now. So these are your scaled down variables for the numerical category also. So now we can combine both of your variables. We have to close the pipeline after this. And for closing this pipeline, now you can again combine these variables together. And the combining process is again very simple. What you have to do is you can use one simple concat operation right here. So I can just update here. Combine both variable types that we have just processed. And for this, we can have like your final features I can add here. This is my variable name I'm writing here. And inside this pd.concat function I can use. And within this, first thing I want to add is your scaled variables. Second thing we have is encoded variables. Two things we have created recently. Here we have the scaled variables, and here we have encoded variables. So both of them I have updated here. And I'll be joining them over column axis. If you keep this axis 0, then they will be joined over the row axis, and that will not be the required format. Since we need to join it over the column axis, accordingly we are writing here x is equal to 1. And we can even look after your final features if they are in the desired format or not. So we can just type final features head over here. So this is now your final feature set. In the beginning, we have all numerical variables, then we have all categorical variables, and this makes up your final data that you can utilize for building your model. So now we have come to the last phase where we can start building your model. And for this, what you have to do is, first I'm writing here task, building machine learning model. This is the main task we have to do. And after this, the first thing we need is we need to separate your training and testing data set. Training data set we use to train the model. Testing data set we utilize to evaluate the model. So we first need to separate them. And we usually prefer to put majority of data into the training set and minority into the testing set. So here I'm writing from sklearn.model selection. We have to import train test split method. This is a very simple method we can apply for splitting your data set, and it gives you 4 outcomes. First is the training feature data set. Second is your testing feature data set. After this, you have next is training target data set and training testing data set. 4 things we get in the outcome. And we just apply your train test split method over here. And this will be applied on your final features that we just created and your y variable, which is the target. Then we have the test size. For example, I use it 25%, means 25% data will go into the testing set and 75% will go into the training set. So accordingly, this set will be prepared. And ultimately, I'm making shuffle is equal to true so that all observations get equal opportunity to enter into training and testing data set. There is no biasing between those observations. And we can ultimately check shape of these variables as well, so that we just know how much we are putting in one category and in other. So shape of the first one, shape of the second one, and then the same for the remaining. So we can just run this one and we can see here, your majority of data set goes into the training part and minority goes into the testing part. So after this, ultimately we can build a model. And for example, I'm building one simple model here. That is your decision tree classifier. Since we are working on classification problems, so I have to use a classifier here. There are unlimited machine learning models that you can use for this thing, but I'm using one basic one here with decision tree classifier. And how we deploy models in your Python, that is very simple. We call it from the library sklearn, and this decision tree belongs to tree module, and we just have to import decision tree classifier. This is the name of the model that we are importing from the tree module of your sklearn library. After this, one more thing we need is we need your evaluation parameters that will be using to test performance of the model. They also come from the sklearn, but from the matrices module, and we can import. For the classification, we need your accuracy score, and we can also have confusion matrix. You can also try many other techniques. We have several options to test accuracy of your model. I'm using just these 2. After this, I'll be building the model. So for this, what we can do here is, first of all, I can declare the initial parameters of my model. I can just initialize it here. I'm using empty brackets because I'm using only default values or default hyperparameter values for decision tree. Then I can fit this model over my training data set, because we train our model using the training data set only. So I'm using them here. After this, we can make predictions. So that I'll be storing in y predict variable, and then we have dct.predict function that we apply on your testing data set. Training we do on both target and features, and testing we do only on features. And then we evaluate it against your testing target. So for this, what we can do here is print accuracy score is the first test I'm conducting. And this I'll be conducting using this particular function from here. So I can use it. And the comparison will be done between your predicted values and your original test values. So I just have to update them here. The same thing you can do for the second variable as well. So I'm just updating it here, and then I'm writing the different variable sequence. This is your confusion matrix and the function you have to apply for the confusion matrix now. This is all about your machine learning model. This part is for training your model as well as making predictions, and then we are making the final outcome evaluation from here. I can run this part. And this will give you an accuracy of 80% right now with the confusion matrix right here. Confusion matrix is basically a combination of true positives, true negatives, false positive, and false negative, which gives you a quick indication about how your model is performing. If you are interested to know more about the confusion matrix, I can explain that. You can ask me in the chat. Then I'll be explaining in detail also. But this is your general description for the model that we have designed right now. So this completes your complete case study. And although there are several modifications that we can do, but that completely depends on your interest, that how you want to modify it. There are so many things that you can still do on this case study. So today we have learned to build a model right from the scratch. We have just understood how we get data, how we explore data, how we plot it, and then how we transform different variables as per our requirement, and then how we build a model. So every part of a data science and machine learning case study we have touched today, and we just completed one case study with this heart disease prediction data set. The source of data set I have also shared. The sheet that I'm using for this coding, this will be also shared with all of you. So those who are interested to learn, they can definitely execute this sheet time and again, and they can learn every part of it. I have added these notes also, the small notes about every section, so that you can just identify what we are doing in every section. And if anyone is stuck anywhere, you have tomorrow's day also. You can ask me if you find any trouble at any point on this case study. So after this, I hope we can start the quiz session. I'm just hoping that you people will participate in the quiz. So I'm just turning on the quiz right now, and you people can just turn on your scanners, and you can scan your QR codes with this, and then we can begin with the quiz. So the link of this I'm sharing in the chat box. If someone wants to join from the link, they can use the link also. You will find the link to join in the chat box. And those who want to join by using the QR code, they can just use this QR code from here. The link is also shared in the chat. I can see 10 participants by now. If anyone else is trying to join, please let me know. If any of you are not working, then also please update me in the chat so that I can start the quiz. There are 11 participants. Anyone else interested to join? Okay, so no one is responding, so I'm just starting this quiz. Okay, so I'm about to stop the quiz now. I hope all of you might have attempted. Okay, so we are done with the quiz also. And if anyone have any queries, please let me know about the session if we have to discuss anything.
Everyone. There is no query, then we can stop the session.